Hello viewers, welcome back to CCV Knowledge Hub. In this session, we are going to learn about quantum numbers, which is very important for State Board, ISC, CBSC, as well as NEET, IIT and JEE exams.
In this session, you are going to learn very important points about quantum numbers. So let's see one by one. So what are quantum numbers? The quantum numbers are the set of numbers used to describe position, orientation of orbitals and energy of the electron in an atom are called quantum numbers. The main thing here, by using quantum numbers, we can find position of electrons and orientation of the orbitals and energy of the electron in a particular shell, how much it is there. So here if you see atomic structure, center we have a nucleus, outermost orbitals, around the nucleus we have orbitals, that is, so according to Bohr's model indicated 1, 2, 3, 4 or K, L, M, N, right? So here if you see in the first orbit we have 1s orbital, in the second orbit we have 2s and 2p orbitals, and third orbit we have 3s, 3p, 3d orbitals, and fourth one if you see 4s, 4p, 4d and 4f orbitals are present. So here quantum numbers are very important to find the electronic configuration. If you want to write any electronic configuration or anything, so it will tell about the main important things. So all these things we are going to learn in this particular session. So first one is principal quantum number, and second one is azimuthal quantum number, third one is magnetic quantum number and spin quantum number. So there are four types of quantum numbers available. Let's see one by one now. So very first one, so in this I am giving very important points, minimum points you have to remember in your board exam or NEET exam, whatever it is. So principal quantum number, very first point I am giving here, it was discovered by Niels Bohr. And second point is it is denoted by n, small n, not capital, right? Capital N. So always it is denoted by small n. What exactly it will tells about? So energy of the shell, and also we can find size and energy of the orbitals. What are the values of principal quantum number? So there are values starts with 1, 2, 3, 4, so on. So if you see principal quantum number n equal to 1, so what it will indicates K shell, and principal quantum number 2, it indicates L shell. Likewise, so 3 indicates M shell, 4 indicates N shell. Right. Let's see other points related to principal quantum number. If you want to know the in a shell how many maximum number of electrons, so by using 2n square formula we can find. So here if you see the maximum number of electrons here K shell, so if you substitute 1 in 2n square, 2 into 1 square, so 2 electrons are available. So L, so that is L shell or second orbit, so that is 8 electrons. The maximum number of electrons are 8 in the second shell. And third shell if you take M equal to 3, so 18 electrons are available. So Y means, so here if you see S, P, D orbitals are present. So S orbital can hold 2 electrons, and P orbital 6 electrons, and D orbital 10 electrons. So total 2 plus 6 plus 10. Total 18 electrons are present. The maximum number of electrons 18. And n shell, if you take, 32 electrons are present. The maximum number of electrons, because s, p, d, f. So 4 orbitals are present. That's why 32 electrons are present in the n shell. And how to find the energy of the orbit? So this is the formula. After substituting all the m value, mass of the electron, z value, and here Planck's constant, h value, pi value, all these things. So after simplification, you can remember always this format, this formula, minus 13.6 to z square by n square electron volts. So by using this formula, you can find what is the energy of the orbit. In a orbit, electron, what is the energy in a orbit, in particular orbit, you can find by using this formula. The main thing, principal quantum number tells about the size and energy of the shell of the hydrogen atom or hydrogen like species, right? So friends, these are the information about the principal quantum number. Let's move to azimuthal quantum number. So azimuthal quantum number indicates a small l, and it was discovered by Sommerfeld. So what we can find by using azimuthal quantum number here, shape of the orbitals. So if you see, quantum number is a set of non-negative integers which defines the shape of the orbitals. So values, if you see, 0, it will starts from 0, 0, 1, 2, 3, 4. And it is also called angular momentum quantum number. So that is orbital angular momentum quantum number. Because we can find the angular momentum. In the next slide, I will show how to find the angular momentum, what is the formula. And very important thing here you have to remember, n or n based on the n value, l values will come. So n equal to 1, l also 1, that is equal to 1s subshell. So if you see n value equal to 2, there are 2 subshells, already we saw, right? So 2 subshells here. If you see this diagram, 2s and 2p. So s always 0 l value and p orbital equal to 1 and n value equal to 3. There are 3 values, l values we can get, 0, 1, 2, and here 3s, 3p, 3d, and n equal to 4. If you see 0, 1, 2, 3 and 4s, 4p, 4d and 4f. So there are 4 different orbitals we can find. So these are the l values. So it starts from 0 and ends with n minus 1. Let's move to other points. So angular momentum of the electron we can find by using this formula, a root of L into L plus 1 into h by 2 pi. By using this formula we can find the angular momentum of the orbital. And if you see this structure, azimuthal quantum number 0, and what is the subshell here? Always L equal to 0 means that is S subshell. The number of orbitals, so number of orbitals, 2L plus 1 formula we can use. So that is 1. So only one s orbital present in the first orbit. And the maximum electrons we can find 2. 2 into 2L plus 1 is the formula. And what is the shape of the s orbital? Spherical shape. And the second one is L equal to 1. The subshell is P. Number of orbitals 3. So the maximum number of electrons present in this p orbital 6. There are three subshells, right? So in this one subshell, we have 2 electrons. So 2 into 3. So 6 electrons. The maximum number of electrons are 6. And what is the shape of the p orbital is dumbbell shape. There are 3 different types of p orbitals: px, py, pz. And next one is d orbital, the subshell. So here azimuthal quantum number always 2 and subshell is d. The number of orbitals 2l plus 1, that is 5. 5 subshells are present in the d orbital. So 5 into 2 is 10 maximum electrons we can find here. Otherwise you can substitute in the 2 into 2l plus 1 formula. That way also we can get 10, because here L value equal to 2 d orbital. So 2 into 2 4, 4 plus 1 at 5, 5 into 2 10. Like this you can calculate. So what is the shape of the d orbitals is double dumbbell shape. There are 5 types of d orbitals are present, that is dxy, dyz, dzx, and dx square minus y square, dz square. Right. So these are the d orbitals information. And next one is azimuthal quantum number equal to 3. So that's subshell equal to f. So number of orbitals is 7. So 7 into 2, or you can substitute the value L value in the 2 into 2l plus 1. The maximum number of electrons in the f orbital is 14. So shape is complex shape. Right. This is the complete information about the azimuthal quantum number. Let's move to magnetic quantum number. So magnetic quantum number proposed by Landé, and the magnetic quantum number denoted by small m, not capital M, always small m, please remember. So it represents orientation of atomic orbitals in the space. So it is the values we can, it is always depends on the L value. So m value, magnetic quantum number values always depends on L value, azimuthal quantum number values. Let's see what exactly that one. So magnetic quantum number, we can have total number of 2 in 2l plus 1. Right, here we will see, for example, we have a subshell S subshell, L equal to 0. What are the m values? Even m also 0. So only 1. So here p orbital, for p orbital L value equal to 1. So magnetic quantum number values minus 1, 0, plus 1. There is a splitting of the spectral lines. We'll see in the next slide what is, why, how many types of splittings it can take here. See, there are 3. And d orbital, if you see L value equal to 2, so m values minus 2, minus 1, 0, plus 1, plus 2. And f orbital, f subshell, if you take sublevel, so L value 3 and the m values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, right? So total 7 subshells. We'll see the different types of splittings. So what exactly this magnetic quantum number explains? Splitting of single spectral lines of the hydrogen atom, right, into the number of lines. There are 2 types of splittings can happen. First one is Zeeman effect. Splitting of spectral lines in the presence of magnetic field, that is called Zeeman effect. Splitting of spectral lines in the presence of electric field is called Stark effect. Right. So if you see here orbitals, S orbital 0, p orbital. So first sub shell -1, middle one 0, last one we will indicate +1. And d orbital -2, -1, 0, +1, +2. 5, right? So 5 subshells. And f orbital, if you see, -3, -2, -1, 0, +1, +2, +3. So there are 5 subshells are available. So this is the information about the magnetic quantum number. These are the main points you have to remember. And let's see spin quantum number. So who proposed this spin quantum number? Uhlenbeck and Goudsmit. Uhlenbeck and Goudsmit. So spin quantum number always denoted by small s. So it represents the direction of the spin of the electrons. Direction. There are two types, clockwise direction or anti-clockwise direction. Values generally, if you take +12 and -12. In a subshell, if you see two electrons, one is clockwise direction it will rotate and another one is anti-clockwise direction it will rotate. That's why, so this is stable. So spins are equal, neutral, +12 and -12. So it will be neutral. If unpaired electrons are present, only +12 will be there. That time some magnetic properties for the elements, we can say some magnetic properties because of unpaired electrons present in the outermost shell. Right, friends, this the complete information about the quantum numbers. So minimum points I given, please remember. So for your NEET exam, IIT, JEE or board exams, it will help. Thank you so much. If you like this information, please subscribe CCV Knowledge Hub YouTube channel. Thank you so much.